Hello class, my name is Embick and today I'm going to talk to you about my project on creating sustainable commercial structures with daylighting. What is daylighting? Daylighting can best be described as the illumination of buildings by natural light. In other words, utilizing the sun's natural illumination while eliminating the need for electric light bulbs throughout the day. According to the Center for Clean Air Policy, buildings account for nearly 40% of global energy consumption. Of that 40% of buildings, 18% of those are commercial, and of that 18% of commercial buildings, 28% of energy consumption can be traced to lights. This is about 5% of all energy consumption globally. Additionally, cooling accounts for about 13% of a commercial building's energy consumption, which can be partially linked to light bulbs emitting heat. So how can we decrease this energy consumption? This brings me to the main objective of my project, to reduce carbon emissions through proper daylight usage and eliminate electrical lighting in commercial buildings when possible, all while decreasing energy usage throughout a building's lifetime. In analyzing the use of daylighting to decrease the energy consumption of light bulbs, it's important to consider that daylighting is often a system of techniques and components, rather than just one component. The combinations of these components and techniques allows a building to draw sunlight efficiently. Some of these techniques include smart shading devices, which are essentially just blinds that adjust relative to the sun's positioning automatically, active skylights, which are smart skylights that also adjust relative to the sun's position to allow for optimal sunlight entrance, and passive skylights, which are just standard windows in the roof which allow sunlight to pass. Another technique not listed would be positioning a structure in a manner that creates an efficient sunlight entrance into the building. Another important technique is window glazing, which is just the method of incorporating gas such as argon or krypton in between window surfaces to absorb UV rays. Window glazing is beneficial in both warm and cold climates because it acts as an insulator to absorb outside heat in the summer and reflect it back out into the environment, while absorbing indoor heat in the winter and keeping it in the building. Here we see an example of successful daylighting techniques in Hearst Tower, which is located in New York City, New York. It uses proper window glazing and interior skylights to keep the building well lit and also keep the summer heat and winter cold out. Another example of proper daylighting is the Bullitt Center in Seattle, Washington, which is also regarded as one of the greenest buildings in the United States. The building uses large glazed windows throughout the structure to keep it well lit and illuminated. Here we analyze the benefits of daylighting based on different perspectives. From an ethical and environmental perspective, energy production continues to emit harmful greenhouse gases, which is a big step to decreasing some of these gases over time and creating a more sustainable system in commercial structures. From an economic perspective, the upfront cost can be larger, but studies by the National Institute of Building Sciences suggest that increasing an initial cost of 25 cents per square foot to 50 cents per square foot on natural lighting can save from 5 to 20 cents per square foot annually, depending on the efficiency of the structure. And from a social perspective, studies from the American Council for an Energy Efficient Economy have shown that productivity amongst the average working person has increased when incorporating daylighting into an office setting. The U.S. population in 2017 was 325.7 million people and is expected to rise to 458 million people by 2050. Using an IPAT analysis, if we were to decrease the environmental impact by 10% by the year 2050, how would this affect affluence if emissions of CO2 per kilowatt hour was to remain the same? Here you can see the calculations. Based on an average electrical emission value of 1.22 pounds of CO2 emissions per kilowatt hour, which is assumed to remain the same from now into the year 2050, we would need to decrease our affluence by roughly 57%. Thus, incorporating daylighting into commercial buildings is a big step to achieve this number. Now let's look at some advantages and disadvantages. As mentioned before, an advantage to daylighting is the decrease in energy consumption. Along with this, the HVAC energy costs will also decrease as a result of properly controlled natural lighting. An increased productivity in office settings would also be a noteworthy result. A disadvantage of daylighting is the initial investment, which can be larger than any typical structure that is built. In addition to that, the owner also runs the risk of improper construction and can actually create a less efficient building. But this comes with experience in green construction. As the more buildings we create, the better that companies will become at designing them with the given circumstances and location. So to wrap things up, daylighting is a step to decreasing the energy emissions from lighting. There are numerous methods to implement, such as window glazing, skylights, and smart shades. Daylighting also decreases the heating and cooling emissions. And from the IPAT analysis from before, a 10% reduction in CO2 emissions due to lighting by 2050 requires about half the use of lighting per person in commercial buildings. Thank you for your time, and if you have any questions, please feel free to message me on web courses.